Hello everyone, my name is Mauricio Verano, and today I'm going to present our paper called Getting Grammars into Shape for Block-Based Editors. This is a joint work with Tom Beckman, Thijs van der Storm, Robert Hiersveld, and Jurgen Finju. First, we need to know what block-based editors are. And block-based editors are programming environments that use these visual representations of language constructs. They have different characteristics. First, they have a value input. So value inputs are used to represent expressions. Then we have labels, as in most programming languages. And then we have statement inputs. So statement inputs are similar as value inputs, but their main difference is that statement inputs are stacked in a vertical way, while value inputs are stacked in an horizontal way. These are some of the most popular block-based programming environments. These environments are typically handcrafted, so that makes them difficult and hard to develop, especially when we want to offer such an interface for a domain-specific language. So having this into account, in previous work, we developed Kogi. Kogi is a tool in which we make a mapping between context-free grammars and block-based environments. So it is important that our main concern here was to being able to reuse existing grammars. So here on the left-hand side, we can have a look at a grammar for MiniJava. So in this grammar, we use it to generate a block-based environment using Kogi. And this is the resulting block-based environment. So now let's have a look at how these environments work. So first, we want to write this program, this small expression. So we are going to use the method called block. And now we want to define the identifier of the method we want to call. So we use the identifier, we change the name. And now we want to do the same for the class, but we find an issue here. We cannot add it directly. So we need to add an adapter. And with this adapter, then we are allowed to drag the identifier again. The main reason for this is that Kogi follows a naive approach for generating the block-based editors. Now we want to continue writing our program, so we add an expression list, and now we want to add an addition. Now let's add the operators, so they are numbers. So let's add the numbers, but again, we have an issue here. We cannot add them directly. So indeed, we have to add another adapter, and with this adapter, now we are able to add the numbers. So as you see, this makes the usability of these environments not so smooth. So based on this, we identified several issues. So these issues are described in the paper, but today I'm going to present you two of them. So the first one is related to chain rules. Chain rules are an issue for this naive approach because then we have to add the extra adapters that we saw before. Another issue is with recursive lists. So essentially, users are required to fetch expression lists blocks each time they want to add another expression. So again, this has an impact on the usability of the resulting environments. Based on the issues that we found, so we developed Kogi. So Kogi is an extension of Kogi in which we want to simplify grammars. And the main reason for simplifying grammars because we want to generate a better block-based editors from grammars. We want to reuse existing grammars. So to achieve this goal, we have defined an aesthetic criteria. So this criteria has been defined by studying different block-based environments like Scratch, MIT App Inventor, and so on. We define the following criteria. First, we want to provide high-level constructs. We want to offer pre-filled leaf nodes, so users don't have to drag and drop every single block. We want to enable the reconfiguration of blocks. This is important, as we saw on the most popular platforms. We want to make it explicit the block types. And finally, we want to map lists to mutators or statements. So after applying Kogi to our initial MiniJava grammar, well, we go from the top part of the screen to a grammar as shown in the bottom part of the screen. So as we see here, there are some simplifications that were applied, and those simplifications are important when we want to create the block-based editor. So if we generate the same block-based editor but using Kogi, we can see the resulting environment here. So we are going to add a method call again. It's the same expression that we wrote before. Now we add another block for the name of the class, in this case math. Now the function we want to call. And now we can just add our expression. So we want to add an addition. So we can just add the block and we can write the numbers we want to compute. So as you see here, this is a more concise version of the one generated by Kogi, and there are other improvements that we will discuss later. I want to bring you back again to this case because this is another example in which instead of having to drag and drop different blocks, well, users can reconfigure a block, which is something that we found in the static criteria. Now let's have a look at the architecture of Kogi. So Kogi is divided in 4 main phases. So the first one is optional, and this one is about eliminating operator precedence encoding. So this is mostly useful for grammars written in formalisms that does not have explicit support for operator precedence. Then the second step is where we remove unnecessary syntax, and then we apply merge rules. So we define 5 different steps for merging rules. In this talk, I will focus on 2 of them, and the others, if you're interested, please, I invite you to read our paper. And finally, after merging the rules, we proceed to the block generation. Now let's have a look again at some of the merging rules that we define. So the first one is inlining simple rules. So we define simple rules as a production rule that is not a lexical rule. It has at most a single non-terminal but arbitrary number of terminals. And finally, it's not a top-level non-terminal alternative. So let's have a look at a simple rule. So for instance, here with expression list. With expression list is defined as an expression star. And if we look at method call, we see that there is one reference to the expression list. And we want to obtain something like this. We want to remove that simple rule and we want to inline it. So instead of having expression list, now in the resulting environment, we have expression star directly. And as we see on the bottom part of the slide, there is already an improvement because users have to drag less blocks. And again, this is important because we define this as part of our aesthetic criteria. Another step of merging rules is merge structurally identical terminals. So this is, again, important because we analyze the structure of the grammar, and based on the structure of the grammar, we try to find some patterns. So for instance, here we see that for expressions, when we have binary operators, well, they follow the same structure. The main difference is only the operator. So what we do is we simplify it in this way. So we have a left-hand side and a right-hand side, and then in the middle, we have the operators. So again, this helps us to define better blocks. As we can see on the right-hand side, we see that the block, instead of having 4 blocks, we have just one single block, which is reconfigurable. So this was interesting, but we wanted to see it like in action. So how it behaves for different languages. So we define different case studies in which we evaluate different languages. So we go from programming languages like Java, JavaScript, to domain-specific languages like state machines, sonification blocks, a language for configuration cloud resources. So now let's have a look at the numbers. So we measure the number of blocks, the number of categories in the palette, and the number of blocks required to write a program. Overall, we found that there are reductions of 40 till 50% in the number of blocks that were generated or that were required to write a program. And we focused on this reduction because this is one of the aesthetic criteria that we defined, and we want to offer high level blocks, so which makes easier for users to describe their problems. So based on our results, we identified the grammar decomposition, how authors write their grammars have an impact. So for instance, when we have like high decomposition, well, there are risks that the grammar becomes even more difficult. So that's why we have some red numbers here. For instance, for Java 8, we tried to apply Kogi, but we ended up with a programming environment that contained even more blocks than before. So this is something that still needs to be studied, why this is the case. We noticed that mainly for Java 8 is because there are many optional productions in the grammar, so that makes it a little bit harder. Based on medium decomposition, so for untyped languages or domain-specific languages, we noticed that the results of Kogi are quite good compared to Kogi. So this is something interesting. And when there is low decomposition, that means that the grammar is already in good shape, so there is no need for doing transformations. So there are almost no changes, like as we see here with state machines. So there were little things that can be improved. Some of the limitation is that, for instance, Blockly only allows you to choose between a statement and an expression output. So this makes it a bit difficult. There is nothing in between. Also labels, well, it's difficult to know where to leave spaces, where to add new lines. So this is something that maybe we require some extra information from the developers. And finally, it's also important to consider, well, whether we want to offer a lot of flexibility or perhaps some convenience. So for instance, here on the bottom part of the slide, we have the same language construct represented in Kogi and Skogi. And depending on the language, maybe we want to have a single block that contains all the information, or we want to provide different blocks so that we can reuse some of them. So to conclude this talk, I showed you how we improved the generation of block-based editors from context-free grammars. And based on our aesthetic criteria, we obtained a decrease in the number of blocks required for creating programs, and also the generated ones. But we still need to investigate if that has an impact on the users. So this is what we want to evaluate as a future work. We want to conduct a user study to check whether this has a positive impact on the users. Thank you so much for your attention, and please let me know if you have any questions.